Hello everyone, and welcome to How-FixIT. Today we're doing the ultimate maintenance service on the PlayStation 5 Slim, the kind of deep refresh that can bring temperatures down, reduce fan noise, and improve long-term reliability. In this video, I'll walk you through the entire process step by step. We'll fully disassemble the PS5 Slim, deep clean the heatsink and power supply vents, replace the APU liquid metal, and upgrade the thermal interface using fresh thermal putty for better, more consistent contact. I'll also guide you through full reassembly and post-service checks so you can put everything back together. Before we get started, here's what you'll need: a screwdriver set with Torx T8 security and Phillips No. 1 bits, plastic opening tools, tweezers, and an anti-static brush. For liquid metal replacement, I recommend thermal Grizzly Conductonaut. I'll be using thermal putty to replace the pads, and I'll explain during the process which materials and thicknesses are best for the PS5 Slim. Isopropyl alcohol, 90% or higher, and cotton swabs for surface preparation. I've included links to all the tools in the video description below. I also highly recommend using a magnetic mat. The PlayStation 5 Slim uses many screws of different sizes. Organizing them prevents mix-ups and makes reassembly easier. A magnetic mat helps you prevent them from getting lost, since they stay attached to the mat. It's a simple but very helpful tool when working on complex devices. Alright, let's begin. Place the console on its side with the PS logo facing up. The top cover is secured with clips. Lift the front edge to release them. Clean any dust from the back of the cover. Thoroughly clean the ventilation grille. Use a vacuum with a crevice or dusting attachment to clear dust from the air vents. Blocked vents restrict airflow and raise temperatures. Repeat for the second cover and clean out any dust. Dust in the ventilation holes reduces cooling efficiency and impacts performance. Flip the console and remove the remaining two covers. Clear dust from the shell, paying attention to ventilation holes. Heavy buildup forces the fan to spin faster, increasing noise. Remove the 4 screws. Remove the plastic cover over the fan connector, disconnect the cable, and lift out the fan. Use a brush and, if needed, a vacuum with a dusting attachment to remove stubborn dust from the blades. Residual dust roughens the blade surface and recirculates through the console. A clean fan is quieter, more efficient, and helps stabilize temps. Move on to the heatsink. The fins often collect dust, blocking airflow and reducing heat transfer. Regular cleaning prevents overheating and helps avoid component failure. However, access through the fan opening is limited. You can try cleaning the heatsink through this opening, but it's only a superficial fix and won't address power supply overheating as airflow runs through the console and the power supply. We'll continue disassembling to ensure a proper deep clean. Use the cutout on the bottom corner of the disk drive to lift the right edge and disconnect it. Remove the screw securing the expansion slot cover. Remove the M2 SSD screw, lift out the SSD and the spacer. One screw is hidden under a warranty sticker. Lift it with tweezers and remove the screw. The PS5 Slim hardware warranty is 1 year from the original purchase date. If your gaming console is over a year old, you can safely remove this sticker. Remove 9 screws, then lift off the plastic cover and clean any dust. Flip the console and remove 2 more screws. Remove the 4 screws securing the metal cover. Press the small metal latch on the connector to unlock it, then pull the cables straight out. Disconnect the antenna cables and free them from the housing routes. The power supply connects to the bottom left of the main board with metal prongs. To safely free the board, use a plastic spudger from underneath and lift the board off the prongs. The PS5 Slim cooling system pushes air through the heatsink and the power supply, so dust accumulates at the bottom of the case and inside the power supply vents. This can overheat the power supply and reduce overall stability, causing shutdowns and potentially damaging the power supply unit. Thoroughly clean the power supply ventilation holes to keep the system stable and extend component life. Now you have full access to the heatsink. Brush the fins until completely clean. A clogged heatsink can't dissipate heat, forcing higher fan speeds and risking thermal shutdowns or component damage. Inspect the fins. They should be clear of dust and debris. Cleaning is complete. Next, we'll replace the thermal pads and service the liquid metal. Remove the 30 screws securing the top metal plate. Use a spudger to work around the perimeter and lift the plate. Thermal pads bond it to the board, so expect resistance. You'll find thermal pads on the back of the top shield plate. They transfer heat from the motherboard and can lose elasticity over time. Similar pads are located on the back of the motherboard. We'll remove the board and replace those first. then return to these pads. If the mainboard is dusty and you choose to clean it, use only an anti-static brush. Remove the 2 tension bracket screws alternating turns to keep pressure even. Don't remove one screw fully at a time. Uneven pressure can damage the APU. Work slowly and don't slip the screwdriver. Scratching the board can cause permanent damage. Remove 2 more screws securing the mainboard. Gently lift the bottom left corner with a plastic spudger to clear the power supply prongs and lower plate. Remove the mainboard, flip it over, and lay it carefully on the housing. Now, let's move on to replacing the liquid metal. Prepare the surfaces. Degrease the APU and the heatsink cold plate with isopropyl alcohol and cotton swabs. Gently wipe until mirror clean. The silicone die should be mirror clean and completely residue-free. Clean the cold plate the same way. If a bubble of old liquid metal appears and you don't have a fresh tube, you can collect it with a syringe, but don't mix with new material. Attach the micro tip to your liquid metal tube. Carefully apply a small drop of liquid metal to the silicone die, just enough to cover the APU once it's spread out. If you dispense too much, as I demonstrated, it can pool or overflow, causing uneven contact with the heatsink, which lowers heat transfer. If that happens, collect the excess with a syringe and reapply. Liquid metal is extremely efficient, so a very small amount is all the APU needs. Avoid regular cotton swabs, they shed fibers. Use lint-free or liquid metal safe swabs. Spread the liquid metal into a thin, uniform film. No clumps, no bare spots, light pressure only. Apply a very small amount to the cold plate and spread thinly as well. The goal is to obtain a thin, even layer that fills microscopic gaps between the APU and cold plate. Thick layers insulate and raise temperatures. Now, let me show you how to tell if your thermal pads need replacing. First, do a visual check. Carefully lift a pad and look for dryness, cracks, shrinkage, or tearing. If it looks brittle or has lost its elasticity, it's time to replace it. Next, test compression. Press lightly. Good pads should spring back. If they stay flattened or feel too thin, they may not be making proper contact, which reduces heat transfer. Finally, check tackiness. A healthy pad should feel slightly sticky and cling to the surface. If it's dry, crumbly, or won't adhere, it's no longer effective. If you notice any of these signs, replace the pads. The pads in this video are still flexible and transferring heat well, but I'm going to replace them anyway, so you can see the full process. Now, let me explain why thermal putty is a better option than traditional thermal pads for the PS5. Thermal pads come in many thicknesses, usually from 0.5mm to 3mm, and they also need to be cut to precise shapes for different chips and component clusters. That makes pad replacement more time-consuming, and it's easy to choose the wrong thickness. The PS5 Slim uses pads of different thicknesses across the board, so finding a perfect aftermarket match can be difficult. Thermal putty solves that problem because it conforms to the exact gap between each component and the heatsink or shield. It spreads evenly under pressure, maintains consistent contact, and helps transfer heat more reliably than pads that are slightly too thin or too thick. Now, let's pick the right thermal material. For the PS5 Slim, the best like-for-like upgrade over stock pads is Thermal Grizzly TG Putty Advance. It balances performance and ease of use. If you want maximum thermal headroom, choose TG Putty Pro. The TG Putty Basic version has lower thermal conductivity and is only worth considering if cost matters more than performance. I recommend choosing Advance or Pro for PS5 Slim. For your convenience, I've included a link to this material in the video description below. Use only a plastic tool to lift and remove old pads to avoid scratching the metal. Wipe all pad areas with isopropyl alcohol for clean adhesion. Use only a plastic spatula to lift off the old thermal pads, and work slowly to avoid damaging the SMD components. Clean the areas with isopropyl alcohol and swabs. Be careful around resistors, capacitors, and inductors. Use only an anti-static brush for residue in tight spots. The board is now ready for thermal putty. You can use the included spatulas, a plastic spatula, or apply by hand while wearing gloves. A spatula spreads wide, even layers. By hand, you can form small granules or pads sized to VRAM chips and SMD clusters. I'll show you how to do this by hand a little later. The next important question is how much thermal putty to apply. Try to match the original thickness of the thermal interface on each component. For example, the VRAM chips typically use a thin layer, so apply only a small amount there. In general, it's better to use slightly more rather than too little. Under pressure, any extra putty will compress and squeeze out, filling the gap properly. But if you apply too little, you can leave air gaps, which reduces heat transfer and can lead to overheating. Some SMD components originally used a thicker thermal interface, so apply enough thermal putty to fully bridge the gap between the component and the metal cover. You can use blunt-ended tweezers to shape the putty into a small pad before installing the cover. Once the cover is tightened down, the putty will compress and spread evenly to the correct area. If you still have the old pads, use them as a reference. Compare the height and shape your new putty pads slightly taller than the original to guarantee contact. And because thermal putty is electrically non-conductive, it's normal and safe if a bit of excess squeezes out around the edges of the component. As you can see, I didn't apply thermal putty to the first and last power inductors, because they didn't have any thermal interface from the factory. That could be for cost savings, or simply because those parts don't require additional cooling. However, if you feel it's necessary, you can apply a small amount of thermal putty to those inductors as well. I've finished replacing the thermal pads on this side of the motherboard. Now let's take a look at the final result. Now it's time to reinstall the motherboard. When seating the mainboard, pay close attention to the metal prongs. Align them carefully with the power supply socket. Make sure the two notches line up perfectly. That's your confirmation the board is fully seated in the housing. Use only a plastic tool to remove the old thermal pads from the back side of the motherboard, including the SSD controller area, and any nearby SMD components. When you remove the old thermal pads from the VRM area, be extremely careful. These big metal blocks are the chokes and MOSFETs, but around them you can see lots of tiny rectangular SMD resistors and capacitors. They are very fragile. Always lift the pad straight up using a plastic tool and peel it slowly. Do not drag the pad sideways or scrape with force, otherwise you can easily catch one of these tiny parts and rip it off the motherboard. If the pad is stuck, gently loosen it from the edges first or slightly warm it up, and only then remove it. Take your time. Don't rush any step. Patience is the key to a clean, successful repair. Once the pads are off, wipe every contact area with isopropyl alcohol to remove residue and prep the surface for the new interface. For tight spots or leftover particles around small components, use only an anti-static brush, never metal tools. Next, remove all thermal pads from the top metal cover as well, and clean those pad contact zones with isopropyl alcohol. Now apply thermal putty to the motherboard components the same way as before. Keep in mind that some areas originally used thicker pads, so apply a slightly larger amount of putty there to ensure proper contact once everything is compressed. For smaller components, you can apply thermal putty by hand, but I strongly recommend wearing gloves. Skin oils, dirt, and sweat can contaminate the material and reduce thermal performance. Shape small pieces, place them directly on the components, and let the metal cover pressure spread the putty evenly. If you prefer, you can also shape and position the putty using a plastic tool. At this stage, all required motherboard components are covered with thermal putty, and we can take a look at the final result. Now we can move on to reassembly, then test the PS5 Slim under load to see how it performs with the updated thermal interface. Secure the mainboard with 2 screws. Install the bracket with plastic arms first, ensuring the pegs fit their cutouts. Place the metal bracket on top and align the screw holes. Tighten the 2 screws alternately, a few turns at a time, to apply even pressure on the APU. Don't fully tighten one screw at once. Place the top metal plate and slightly press it down. Secure it with 30 screws. Route and reconnect the antenna cables in their original positions. Insert the ribbon cable into its socket, install the metal cover, and fasten its screws. Install the plastic cover and secure the screws. Flip the console and fasten 2 more screws. Reinstall the disk drive. Hook the left edge into its cutouts, then press the drive so the bottom right connector seats fully in its socket. Reinstall the M2 spacer, the SSD, and tighten the screw. Install the fan, connect its cable, and secure the 4 screws. Reinstall all covers. Align the hooks along the edge, then pull the opposite edge until the grooves snap into place. Repeat for the remaining 3 covers. The PS5 Slim is now fully assembled. Connect it, power it on, and test it under load. Recheck after 24 hours. After a few warm-up cycles, the system can settle slightly. Verify temps and fan noise again. If you found this guide helpful, give us a thumbs up and subscribe for more tech tips and guides. Visit our website for more tech insights and do-it-yourself guides. Remember, every tech challenge is an opportunity to learn and grow. By the way, if you spilled sugary water on your PS5 controller and the buttons are sticking, check out my tutorial on how to clean and restore the DualSense controller. For additional details, check out the useful links in the description. Thanks for watching How-FixIT. See you in the next video.